Alright students, so this is on page 112 of the notes, and this is example 10.2. We want to compute the correlation coefficient and the coefficient of determination from example 10.1 and give its interpretation. Now Pearson's correlation coefficient has this formula. And it looks complicated, but if we recall, we already found these things from before. Now I'm going to do this computation by hand, but remember that your calculator can give you r, and you can manually find r squared rather easily. If you're doing it by hand, you need the sum of the x's, the sum of the y's, the sum of the x times y's, as well as the sum of the x squareds and the sum of the y squareds. Once you know all that, you can just plug in directly to your formula. You'll also need to know n, of course, which was 10. So plugging directly into the formula, we have n, which is 10, times the sum of the xy's, which is 3764, minus the sum of the x's, which is 145, times 212, the sum of the y's, all over the square root of n, which is 10, times the sum of the x squareds, 2785, minus the sum of the x's, parentheses squared, and that's all under square root, times another big square root, which is n, times the sum of the x's, sum of the y's squared, 5320, minus the sum of the y's, which is 212, parentheses squared. Again, watch your computations and your order of operations. If you do it correctly, if you do the top part, you should be getting 6,900 if you do it in pieces. If you do the bottom square root, that should have turned out to be 82.61. And the second bottom square root should have turned out to be 90.86. if you're breaking it into pieces. You should come out to approximately an answer of 0.919 for r. Now if you want to do the interpretation, which I strongly suggest that you do, it's the correlation coefficient is, and you put in what it is, 0.919, which indicates, and now you want to talk about the relationship. Is this number positive or negative? It's a positive, so it's a positive correlation. And is it close to 1 or close to 0? This is pretty close to 1, which indicates strong. So I'm going to say strong, positive correlation between your x variable, which is TV ads, and your y variable, which is car sold. Okay? So the interpretation, again, is the correlation coefficient is 0.919, which indicates a strong positive correlation between TV ads and cars sold. This is a very cookie-cutter type interpretation, so feel free to use it. The blank spaces are what can possibly change. This is R. This is where you're talking about the strength of R and what type of correlation, positive or negative, or no correlation. This is your x variable, and this is your y variable. Now the coefficient of determination, that is just taking R and squaring it. And it turns out to be 0.84494. So its interpretation is the coefficient of determination is 0.84494, which means now we want to make this into a percentage and round it to, I suggest, about 1 decimal place. So this would be 84.5% of the total variation in your y variable, which is car sales, is explained by your x variable, which is number of ads. This is another cookie cutter interpretation for the coefficient of determination. Again, for the coefficient of determination, you want to square r, get a value, turn it into a percentage, and interpret it as 84.5% of the total variation in the y variable is explained by the x variable. And be descriptive. Say what the y variable is and what the x variable is if you know what it is. Car sales and TV ads. And that is the coefficient of determination as well as the correlation coefficient. Doing it by hand. Remember, your calculator can give you the correlation coefficient. You have to find the coefficient of determination yourself, which is very easy because you just have to square it.